Thank you really a lot for this very interesting and comprehensive presentation. I would like to ask if there are any questions. So, yeah, Professor Zakanika.
I have a question concerning the first project that you showed us, and it is about the fire treatment. Did you use any fire retardant, which, I mean, the one that it was all exposed, no fire retardant, just because of the section of the elements?
Yeah, you have, at the time, because it's only a two-story building, so we were able to use this calculation method that you calculate a little bit additional timber, Abbrand, it's the German expression. So in case of fire, the material can burn, it charcoals, it protects itself, the structural integrity is given, and the building won't collapse. So in that respect, actually, timber is more safe than steel or concrete, because in case of steel construction, it'll melt down. But yeah, as you're asking,
60 minutes.
Yeah, it's 60 minutes. So the regulation was asking for 60 minutes of fire protection, and this is what you can achieve with the construction. So also the columns, they were a little thicker on all four sides, and then it's doable.
Okay, thank you.
May I also add something? We just finished one project, Building Wood, where we found out that the wall-to-ceiling ratio is the important factor to determine the fire resistance of the elements. In general, I'm generalizing, it is not, for residential buildings, you can have the timber exposed, generally speaking. The same, and it is not true for offices, malls, commercial buildings, because as you can understand, this ratio is not satisfied. Encapsulation cannot be avoided in these cases. By encapsulation, I mean encapsulating the timber in plasterboard. The newest developments that they have achieved with special types of boards is 120 minutes with a thin timber. So you reduce a little bit the amount of timber that you use, but you can achieve very good results in terms of fire protection. But as I said, this is something that needs to be, the way I understand it, to be implemented in buildings of significant size. Mm-hmm. And as you know, the regulations become more and more strict as you go higher. In the buildings. So the performance-based design in terms of fire protection it becomes a must. Performance-based means that you have the detailed design of the building and you build up your fire safety and fire resistance scenarios, taking into account the use of the building, so you can provide realistic scenarios of how the building would behave under different conditions. A lot of countries adopt these performance-based regulations. Unfortunately, Greece is not one of them. We are still at the old. For instance, Cyprus, that has a lot of influence from the UK regulatory system, they have already adopted the performance-based regulation for the fire safety of buildings. So
I think it's very good, and I think the next level is then, and we didn't show this here, but the approach is currently to use earth rather than gypsum, because gypsum we know is difficult in construction, circular construction with the sulfate content and so forth. And you might know Johanna Lieblich. She's from Helsinki, and they presented at the LEM, is a Earth conference taking place in Germany every 4 years, and there was one in September, and they brought in the potential of applying an earth dry board as a fire safety layer in timber construction, and the idea is that the new Eurocode 5 will pick this up. So this would be really good, because then we have, again, earth as a construction material with a lot less carbon embodied, and it's a circular construction material to overcome this gypsum. But
what we're trying to do with the pavilion, so we have the walls are 30 minutes certificate, and they are going to be cladded with the earth panel as a fire protection. So that would be hopefully the first case that we do it in Germany. So, but that's big steps, and that's a big fight again.
Outside or inside?
Inside, against the fire from inside. And then also, if you go higher, for example, we are also doing the research for another project called a wood scraper in Wolfsburg. It's about 40 meters tower, and then they do sprinkling. And then they have a CLT construction, and the whole structure is visible, but they do sprinkling. That's a little bit another way of protecting them. No?
But as you're asking, we're doing it also in the greenest project. We're doing it outside. That's where Simone is working on the Ecotech wall, because there's also a new, more restrict regulation in place that you need one layer of gypsum board to the outside, or the facade itself should be non-combustible. So we try to have a timber facade, and instead of the gypsum board outside, so in the rear ventilated gap, we want to use an earth dry board. So.
And could you tell us something about the thermal insulation that you use for this building?
Well, we try to use wood fibers.
Because here we only use the blue one. Yes.
Yeah, EPS. Yeah, I mean EPS is. I think the biggest problem to EPS is the very low cost, because it's ecological. It is difficult in certain areas. You need to use it. We try to use glass wool as a recycling product, but also the school I was showing, due to cost, we also used EPS. So sometimes it's really, I think this is the next step.
Not in the main facades.
No, not in the main facade, but in the
ground.
In the ground where you are sort of like attached to the soil. But the idea is really to replace mineral wool or non-ecological insulation with wood fibers, or even better with straw, because straw is a plant that grows, or that you can harvest once a year. So it also safeguards timber a little bit. So these are all the little steps that we can undertake in the construction to improve them.
Still more than 50% of the German timber construction are insulated with mineral wools.
Yeah, unfortunately.
So that's pity.
Yeah.
I think it's a big challenge for the future, going leapfrog forward with this type of construction, especially in an urban environment, because as you know, all this becomes much more difficult to handle in terms of logistics, preparation, storage, and everything else in an urban environment, and going to bigger buildings. So I believe that there is still a lot of thinking to be done in the near future to develop new ideas. The industrialization and the manufacturing of such elements is also a challenge, and I hope we will have a chance to discuss these things. Are there any other questions? Yes, please. Sorry, I cannot see you. Yes? Could you please say your name and just... Okay, thank you.
You mentioned, I understand to use wood construction. Thank you. Is that okay?
Yeah.
Okay, yeah. My question is regarding the widespread use of wood construction. Is that okay? Yeah. Would that still be sustainable? Meaning, there is a trend now, and indeed there is a lot of development in construction methods. So yeah, we can achieve more, but what would happen if suddenly we would start building all out of wood, or especially countries where they don't have forests? What would that mean in terms of plantations, and what's your opinion? I think you mentioned it, you hinted to it, but isn't that also an issue?
Yeah, we're using a lot of wood in Europe as firewood. So if we would use all wood for functional use, that would be the first step. And for sure in Central Europe we could build any structure from wood from today on. So that would not cause problems for the forest. So, but anyway, our model means not to construct so much in new, but to reduce the new construction and just to go in a transformation, because actually in Europe we have enough buildings.
Yeah, okay.
So we have overconsumption, so if we reduce our new construction anyway it will fit. And in a global context for sure we need new forests, we need more agroforestry systems and things like that. And for sure we need to have additional forests for construction, otherwise the system will not work.
But you consider it a good prospect, like long-term?
We need to avoid concrete. So I believe in Asia, for example, where you have a good bamboo, you can also construct with bamboo and other materials, but we need to get out of the concrete systems. Yeah, we just have concrete for infrastructure and slabs, but not any longer for the main construction. That's the biggest problem. But internationally, we don't have the resources, and we have the biggest need because the growing population in China, etc., other countries in Africa will need so many buildings for their people. So that will be anyway a big problem. But we try to get in as much as possible from nature.
Thank you.
And I think there's also earth as a construction material, first of all, in the global south. I think it's much better than concrete because we know that we have very high temperatures out there, and there's a lot of research that has been done that proves that earthen construction are more robust and more comfortable in comparison to concrete. And I think there's also lots of studies going on about, sounds always a bit odd, but mushroom construction and things like that, where you grow really materials through the help of mycelium. And this again is also, I know that at the beginning people were really laughing at such researches, but they're getting more and more results that are reliable. And so I believe it's more a way of changing our thought and to understand that concrete is really, really damaging the environment. So until they haven't developed something where the CO2 emissions to the cement is really zero, it's challenging. And then we have the question of sand, because sand is also a finite resource. So there are lots of issues to be resolved.
I'm aware. Thank you. Yeah, I understand.
Professor Czakanika would like to add something, and then I will give you the floor for some more comments and questions.
Concerning wood, since it is the only renewable material, the other materials cannot compete it. Because, so you plant and you get wood. So if you use wood from forests that are διαχειρίζονται αηφόρα, sustainable use, there is no problem. Actually, the last 20 years, they found out that because of the increase of use of wood in construction, the forests grew in Europe because they use it sustainable. That's why. So I don't think there is a problem there. And for many, many other reasons, it's the only renewable material. So if you use the forest correctly, there is no problem. That's the point there.
Thank you. Yes, please. There are a lot of hands, but yes, please.
Okay. So what I wanted to ask, at first I want to thank you for the presentation, which was very interesting. And I want to ask your role against concrete in some way. I have read some articles and some videos I have watched. There are some teams that they are searching for a way that there are less omission of CO2. So what do you think about that? Is it, and also the way one can reuse that means that you demolish some building that is made out of concrete, and it is scrambled. I don't know. It is. I don't know the English word exactly, but it's been like to be recycled also. So there are many researchers in this way, and I wanted to ask your opinion if you have something that to say on this, because I also thought, as a continuous thought of the previous question, that here in Greece we don't have woods. So we have to bring them from abroad. So how much can this be sustainable, to have all this way to transfer the woods and have everything? I mean, if we are in Finland, for example, or in Japan, or somewhere that they have many woods, I understand that it is more comprehensible, it's more but in Greece, I think it is one of the difficulties is this. The first and the second difficulty, of course, is the different workers that they don't know how to, which you need something, because the difference between concrete and wood, for example, is that in one case you have, you must have experience in order to make the building. So the workers are experienced, and people, in the other case, you don't have that. You have, anybody can do it. So I think that's one of the reasons that concrete has been so much more expanded in construction industry. Thank you.
Okay, multiple questions.
Okay, can I answer a little bit from a mechanical engineering point of view regarding the production of concrete? By definition, the production of concrete involves chemical reactions that cannot be avoided, that produce CO2. The concrete industry, I think, if I'm not mistaken, produces at the moment about 60 to 70% of the CO2 emissions of the construction sector. And by definition, this cannot be avoided. What they are doing two things. First of all, trying to use in the clinker, in the rotating furnace where the cement is produced, waste materials, either from roads or from the construction or other fields, to reduce the environmental impact, and also to use renewable fuels that are based on renewable sources as fuel for the clinker itself. In this way, they try to reduce the CO2, but conceptually, it cannot become zero, which is the opposite of for wood, for instance. Negative, not zero. Negative, yeah.
The other answer is that we tested it in a research project where there were teams working on concrete and also on reusable elements. And the difficulty is that you need a reversible connection between a column and a beam, or as I showed with the school project. So it has been done in the past with the reinforcement on site. So this is obviously very difficult then to reuse elements. There are projects going out at the moment, also in Switzerland. My colleague Daniel Kallenberger is involved in the evaluation. It's super complicated. You need a big saws in order to cut the pieces into to cut a column from a beam and so forth, and the reusability is super limited. So the connectors that you need to bring in for the new construction is not ecological, because you need a lot of material. So this is the downside. In the research project where we were involved, they had also reversible connections, but you need to fill the joint with a grouting that has the same strength as the element itself. And when you put this in, And this is the difference between timber and concrete, because in timber you can have a dry connection. You just have the metal element and you screw it together. In the concrete construction it doesn't work because concrete is much heavier and the grouting has the same strength, and then you can't take it out. That's the challenge. So the reusability of concrete is, to date, they might come up with different solutions. That's obviously not what we can answer now, but to date is very limited. And one thing for the recycling concrete, or there are two things. Recycling is obviously better than binning the material. So you grind it, you take the reinforcement out, and you try to recycle the aggregate. The downside to it is that you need more cement. So the CO2 emissions then to the concrete are higher because of the higher cement content. The benefit is obviously that you need less sand. But the other thing is also it's very expensive, and even in Switzerland, where they promote it a lot, the ratio of recycling concrete overall in the market is very, very limited due to the increased cost. So these are also issues that some need to take into consideration. And the other issue, I believe that, and I think Eike mentioned it, we need to increase the forest in all over the world again, because I believe Greece in the past had probably a lot of forest, but also in Germany we lost a lot of forest, in other areas of the world we lost a lot of forest, and in order to bring the temperatures down again, we need to increase the ratio of forest overall, and then hopefully also out of that an industry that can provide timber to Greece can evolve, but it's obviously not from tomorrow. And of course you're right saying if we don't have access to timber, you need to make a calculation what's feasible and what's suitable in order to order it from a different country. That's for sure.
If I may add a small thing, transportation in the calculation equation is not so much, either in cost or in CO2 emissions. The other thing is, yes, I would agree that in Greece, why to build with timber, everything of timber, because in our tradition is not like this, but in our tradition is a mixed constructions. Let's start using concrete and timber, as it was in our tradition to use stone and timber. I mean, we don't have to go immediately to one to work as in Germany, but let's try to see the combination of materials, because concrete is easy for Greece, is less expensive, but timber can be an alternative for a part of the building.
Well, less expensive is, I think, not the truth, because it's costing our life.
It's a very interesting and vivid discussion, but unfortunately time is running. And I would like to ask Professor Kouvoutsi to come and introduce to us the School of Architecture of the NTUA and welcome us to the meeting today.